Hello, everyone. Today we're going to be solving rational equations. So, as always, pause your video right now, and I'd love it if you would try the Ignite at the top of the page. All right, so for this one, answer is up. You should have gotten your equation to be A equals negative 46 over B, and A should have been 4.6. Now, in order to get that, first and foremost, you had to pay attention to the relationship between A and B. So since A was varied inversely with B, that means we're going to use A equals. Now, just so you guys know, I use a different variable than typically A is the variable that we would use for our constant. But because of the fact that A is being used in this problem, I just picked a different variable for the constant. Um, so once you find your constant, you should have plugged in 28 for A and B as -2, and that allows you to find your constant. So when it says write the equation, that's all it means. It means find the constant and plug it in. But then we want to use that equation because it asks us to find A when B is -10, which is all you have to do is plug in -10 for B, and you have your final answer. So today we're going to get into obviously the solving rational equations aspect. And fun fact, you guys have really actually been doing this all the way since Algebra 1. And typically this method is used usually only on rational equations where there's one fraction on each side and not more than one on each side. So the method that we typically use for these is cross multiplication. So for cross multiplication, obviously, if you guys remember this is hopefully nothing new, but you would take one numerator and multiply it by one denominator. That goes on one side. And then the other denominator by the other numerator. That gets multiplied on the other side. And then you just solve like you would normally, which in this case just means dividing by 8. And 20 divided by 8 ends up reducing to 5 over 2. Now, there is another way to simplify and solve rational equations, but we need another method because that method again only works when you have one fraction equal to one fraction. But what if you have multiple fractions on each side? So that's where this second method comes into play. This method is called just the common denominator method, which is nice because we actually just kind of reviewed going over finding that common denominator earlier this week. So how this works is what we do is we start by obviously finding the common denominator. And this can be for any fraction anywhere in the problem. So even on one like this, when you can use cross multiplication, you can also use the common denominator method. So we would start by pulling anything unique out of each of the denominators. So since each of my fractions have a denominator of x and 5, then together that would create your common denominator. And what we do is we multiply any fraction in the problem by the common denominator. So for example, this first fraction we will multiply, and things are going to cancel pretty nicely. X divided by x cancels, and 4 times 5 ends up leaving us with 20. On the other side, we're going to multiply by the common denominator. Here, 5 divided by 5 cancels, and 8 times x leaves me with 8x. And we can solve the exact same way. Divide everything by 8 and reduce. X is equal to the exact same thing that we just solved. So when it comes to solving different rational equations, it helps to kind of recognize what you're working with. So for example, on example 2 down below, if you'll notice this, since I only have one fraction equal to one fraction, that means really I can choose either of those methods. If I want to cross multiply, I can. If I want to use the common denominator method, that one always works. But if you recognize that this is honestly just one fraction equal to one more fraction, then cross multiplication does tend to be a little bit easier. So obviously 1 times this whole denominator is going to be 11x plus 8. And on the other side, x times this entire denominator goes on the other side. And now there's no fractions. Now I simply I go ahead and I distribute and simplify. So to do that, I'm going to distribute my x to both that 2x and that 5. It's going to leave me with a 2x squared. And x times 5 is going to end up being 5x. Now to finish solving, this is where, since I have a squared in here, that lets me know that we're going to go ahead and factor this. So I'm going to move everything over to be on the same side. Because when you're factoring, remember, it has to be equal to 0. So 5 minus 11 is going to end up being negative 6x, and bring down the 8, negative 8. Now, to solve this is typically where you would go ahead and always start with pulling out a GCF. So I can take a 2 out of each of my terms. And now we're going to go ahead and factor what's left. This guy inside here, you're going to say what multiplies to give me negative 4, that adds to give me negative 3. Well, that has to be negative 4 and positive 1. And then what we do is we take each factor and we set each one equal to 0 in order to find our final solutions. My first one, there's no x's in here, so that one doesn't prove anything or produce anything. So on my other ones though, these you can each solve for x. And wow, that didn't work. And you have your final two answers, 4 and negative 1. Now, the other method though, like for example, number 3, we can't use that method on number 3 simply because we have more than one fraction on each side. Even if it's only on one side, you still then, that eliminates you from being able to use the common denominator method or the cross multiplication method. So we're going to go ahead and use the common denominator method on this one. So let's start with finding our common denominator. First denominator has an x. That definitely has to go in ours. Next denominator is a 4. I'm going to add that as well. My last one has an x, but since there's already an x in it, I don't really have to worry about that one. Now that leads us to our next step, which is just multiply each fraction by the common denominator. On my first one, the x's cancel. 5 times 5 is going to leave us with 25. Next fraction, I'm going to multiply by the common denominator. 4 divided by 4 cancels. We're left with 7 times x. And here, last fraction multiplied by 4x, x divided by x cancels. Negative 9 times 4 ends up being negative 36. And now we can just simplify and solve like normal. I can go ahead and subtract 25 from both sides. Oh, sorry guys, I just realized I multiplied by 5. What's wrong with me? Denominator is not a 5x, it's a 4x. Sorry guys. But either way, well, still simplifies the same. 5 times 4 is 20. And now once we get to this same step, I'm going to subtract 20 to the other side. And we're left with negative 7x equals a negative 56. And then divide, and we're going to be left with our answer of negative 8. So what I want you guys to do right now is I want you guys to practice using the common denominator method. So I would love it if you guys would pause your video, go to the next page, and I want you guys to try examples 4 and 5 right now. All right, final answers are up. For question number 4, you should have got x equals negative 3 as your final answer. And for number 5, you should have gotten x equals 15 and x equals 1 as your final answer. Now, there's one other note to kind of keep in mind when solving rational equations, and that is you really do always want to check your answer. There are some problems that we go through, and this brings us back to the vocabulary from the first page. And that is that anytime you solve using the common denominator method, you have to make sure that going back, that there aren't, or either method actually technically, that there aren't any extra solutions that are produced. Remember, those are called extraneous solutions. So just as a double check, I didn't do this on every single problem and I should have, but you do want to just try plugging each of these each of your solutions back in and just double check that they make the equation actually true. So other than that, though, if you would like to try the U Try Nows, you can. If not, you can now begin working on the homework for the day.